Hello, hello. How's it going, guys? It's Armin, and I'm back with a tutorial. It's been a while, but I'm here. And yeah, your eyes are not deceiving you. We will be making this meme animation today. And I think that it's actually a really good opportunity to just learn some new things and be stupid about it, which is my sweet spot. So yeah, we got this guy. We're gonna come up with the animation. I also added the sound to it, so as you scrub, you can actually hear it. But yeah, you see here we have several different iterations of this animation, and we will be walking through them. Initially, I actually recorded this tutorial a while ago, and it was 2 hours. So that was a bit too long, and also OBS had some issues, so I decided to maybe try to be a bit faster about it, not focus on every little thing, and just re-record. So here we go. So I'm starting from scratch. What the first thing that I would do is bringing in the model. So on Sketchfab, I managed to find this guy. It's actually already animated. So technically, the whole point of this exercise is just like, the whole thing is pointless, but yeah, why not? We can try to set it up ourselves. So the only things that I will be needing from this model is the initial pose, so this guy, and then when it morphs, I will be taking this pose, and then I will do the animation and everything else myself. So shout out to this person for creating this model, and I will put the link in the description so you can download it. And then in the scene file that I will provide, I will not include this model. I would just probably use like a pig head or one of the other test geometries, probably Flippy, but yeah, doesn't matter. Just get it from here. All right, I already have downloaded the model, so I would go to import FBX, and the link is already here, so let's just import it. This is our animation. We're going to jump inside. As you can see, the animation is happening outside on the geo level. We actually don't care about the animation, like I said. We only want the actual geometry, so I will just add a null. I would call it out cat. I will copy this guy. You can even disable it. Put down a geo node, jump inside, object merge, and we will merge our model. Now let's play it. And as you can see, we have the two poses. So like I said, the animation was happening on the geo level, so it doesn't matter. If you do include this option, you should also get the animation. Yeah, but we don't want it. We want to set it up ourselves. We want to essentially do all the morphings and everything ourselves. We want to have a bit more control over it. So first things first, as you see, the model is huge. So we will put down a transform sub. We will bring down the scale to 0.01. So it's a bit smaller. And then what I like to do is, since this model already comes in UV'd, I would add a labs quick material. So add the color texture. In this case, it would be in this folder. So base color. There we go. It's a bit easier to work with it like this, I think. And as I scrub, I can see that I think here on frame 25 to 26, on frame 26, we are switching. So I know that what I have to do is 2 time shift nodes. First one, I will set it to frame 1, and then the second one, I will set it 26. So as you can see, it's not moving anymore, and we have both of our poses. Okay, so let's start working with this guy. So our animation is gonna have 2 phases. Let's analyze it. We have this first pose, we have our second pose. We're trying to morph between them. Well, of course, you can use blend shape. So connect them in, and we're blending. Awesome. Then let's add a transform node because we want to do the rest of our animation. And as always, it's based on time. So either @ frame or @ time could work for us. In this case, I would use @ frame. So it's already gone. Why? Because frame starts from 1. So I would add frame -1. And now as I play it, my model will go all the way up to infinity. And then I would just copy the same thing, put it in rotation. Maybe let's just disable this one so it doesn't get out super quickly. So it's rotating around. Okay, nice. What else do we need? I'm gonna come back to my blend shape first and just animate this parameter. So I'm gonna say, let's say 24 frames of just rest. So I will animate it here, and then over the next 24 frames, go to 1. It's probably too slow for this animation actually. So maybe rather than doing that, let's just, yeah, let's do it over 6 frames. This is a bit more logical. Yeah. So it's faster. And then we're also rotating around. But the problem is this doesn't make sense because the actual meme, the guy will not start just turning around immediately. There's going to be like a pause. So how can I do that? I know I'm going forward 24 frames in time here, right? So what I can do is just -24. Or actually, in this case, I think 23, right? Or what am I? Ah, no, never mind. Actually, 24 is correct. But essentially, I'm putting it on minus. So what's happening here? This is correct. The only thing is it's not finished. We are trying to... basically, what we want to achieve is that we want to have 0 in here until we reach 24, right? So how do we do that? Super easy. Just clamp it. So put a clamp node, and then put it between that and just $f, and here it doesn't matter what you put as max. And of course I finished it with a semicolon. I thought it's vex, but it's not, it's just an expression. So there we go. And then on frame 24, this guy will morph and start to rotate, right? There we go. And it's super slow, but that's not a problem. You can just speed it up, right? So how do we do that? Just multiply it by value. So in this case, I would multiply it by like 10. So it's faster, and then multiply by like 20. I don't know. Something like this, which is fine. For translation, we would do the same thing, but this time I will use the sine function. So I would do sine of @frame. Again, -24, because we want to have some sort of pause in there. Let's view it. It's going from -1, going all the way up, and then coming, stopping in the middle. So let's just extend the timeline. Goes up, rotates, comes back, exactly that. But we don't want it to like go to negative. We only want the positive. So super easy. What I would do is just put down an absolute node. There are several ways that you can do this. I like to use absolute. You can, but if you don't like the way the animation would look, you can actually put down, for example, fit 0, 1, fit 1, 1, because we know sine is always between -1 and 1. So just fit it like that. Absolute works fine in this case. I don't have a problem with it. So we do this. This is our movement. But I'm not super happy about it because we're starting all the way in the middle. It feels a bit weird. Why is that? Because again, like before, frame -24 is going to be a negative value. So we need to clamp it. So before putting it through the sine function, I'm just going to copy this clamp. And it should be basically what you put inside your sine function. And now it's doing what I expect. The only problem is that obviously the frequency of this jump is a bit weird because I don't have any control over it. And also I don't know how far it's gonna jump. So super easy to fix. Just multiply your clamp, similar to what we did here. Just multiply your clamp by a value. So this is the brackets here, so it would be this one. So there we go. I would multiply it by 20, and then I would just multiply the results by also a certain number. So this one would be our range, how high our cat will jump. I'm not going to include that right now, just so we look at it step by step. So as you can see, it's much faster now in the jumping, but it's still the same range. And then if you multiply it by 0.2, you also set the range. And very, very easily, you can just set up parameters here. For example, let me just pause it. You can bring a float, paste it here, call it spin, for example. And then we will copy this parameter, come here, paste relative reference, and now we give it 20. So it's being controlled by this value. And then you can just, yeah, you can just play with it, set different values. And same with these two. But this is not super easy to do. Like we are writing things here, it's getting too big, it's not easy to control. So what's the better way? Well, the better way is always Vex. Let's just use Vex instead. So what I'm gonna do is I'm just gonna copy this section over. I'm not gonna put down the blend shape. Instead, I'm gonna put down a wrangle node. So what I wanna do is what the blend shape node does internally. So I will connect my first input here. Essentially what I wanna do is I wanna read the position from this initial pose. I wanna read the position from this secondary pose, and then I just wanna blend them together. So let's also wire this guy to the second input. What I will do is, let's comment it out. So first step is blend shape. I'm just gonna read the position. So position 1 is V at P. Position 2 is, in this case, we would use the point function. So we would read from the second input, which is 1. So 0, 1, 2, 3. So we're reading the P attribute and assign PT now. There we go. So this is the second input, and let's just define our bias, which would be literally this handle here, the parameter that we had. So I'm gonna call this one bias, for example, and I'm just gonna give the channel. So CHF bias, semicolon, don't forget that. And then what I want to do is I want the positions to be equal to lerp, which is the function in Houdini that does linear interpolation. So you're interpolating between two values. What does that mean? It's a mix node. If that's a big word for you, it is a big word for me. English is not my native language. So lerp is just a mix. We're mixing between P1, P2, comma, and our bias. There we go. Create the slider, and as you can see, we are morphing. All right, let's take it to the next level. Let's add the spin. I'm just gonna do it here as well. I'm not gonna put down a new node. We're doing the spin now. So what do we need for a spin? Is a rotation, right? So rotation, we just write down the rotate function. What does rotate need? Rotate needs a matrix, it needs a float amount, and it needs a vector axis. So super easily, let's just write all the ingredients and axis. There we go. Obviously, we're gonna get an error because we haven't defined it. So let's define them. I would say matrix M is equal to ident. This would be an identity matrix. You can look it up. Identity matrix is essentially this matrix. This is the function. So you have ones here in the middle, and then everywhere else it's just 0. So in our case, we have a 4x4 matrix, so it would look something like this. And essentially, we would be multiplying our matrix at the end with our point positions to get that rotation. You can look up rotation matrix and how it works, and I'm sure there are really great tutorials out there for just explaining what's happening here. And what we're doing is super simple, so you don't really need to have a full grasp on matrices. Even I don't fully understand matrices. I didn't study math. I regret that, by the way. So what do we need? A float. So it's called amount, and I'm just gonna set it to slider. And last but not least, we need a vector axis, which would be the axis of our rotation. In this case, we know it's rotating around y. So 0, 1, 0. There we go. So we are rotating around that. I'm just going to create my slider, and I will start rotating, and I'm not seeing anything. Why? Because we need to multiply our position by this value. So v at p, multiply equal by m. And by the way, if you're confused why I put this function, but I didn't put any like variable before it, like I didn't define it as, I don't know, float x equal to something. This is a function that doesn't need to be written on a variable. Essentially, you're defining your matrix up here, and you're rotating it. So this is the parameter that you're rotating. So the m value will be the thing that's updated. And as you can see, we are rotating it now. And our normals are a bit messed up. So what you need to do is also multiply your normals by m. Or if you're lazy like me, just put down a normal note at the end and let it calculate it on every frame. But there is something weird here. And it's that when I put one what? Like this is not 1 degrees clearly. What is this one? What am I getting? Well, it's in radians. So essentially what you would put here is actually define this amount inside a radians function. And now this would be treated as a value, as a degree. So now 1 is actually 1 degree. You can see 90 is, if I put down here, yeah, 90 is 90 degrees, 180 degrees. And technically you can also put down, for example, pi here. That would also work. So if I just take this whole thing off and just use pi. Pi is a variable that Houdini recognizes by default, and you can see pi equals 180 degrees. If I put down half a pi, it would be 90 degrees. Pi divided by 4 would be 45 degrees, something like that. But I mean, that's not super easy to do, and let's just do it like this. And sometimes this note does some weird stuff. If you move it around, the quick material will reset. If it doesn't, just remove it and place it again. So we have our bias. Ooh. And we also have our amount. And what else do we need? We need to jump. So let's comment out jump. And jump is very similar. Similar to rotation, it also needs a matrix. We call it n. It's ident, and then jump is a bit translation is a bit easier. So the translate function only needs 2 arguments. So we have a matrix and a vector amount. So I would in this case call this vector move, because we already used amount up there. So I need to have a unique name. And vector move, in this case, which is what we called it, is equal to something, right? Just to stay consistent, let's just call it jump. Jump is a bit easier. And we need to set a value here. So by default, of course, we would define a channel vector and just put a value in there. But I'm not gonna, I'm only jumping in the y-axis, so why bother? I will put down a set node and set function. And basically set 0, 0, 0 means, or for example, in this case, 0, 1, 0, these two are the same thing. 0, 1, 0, whether you define it with curly brackets or whether you define it by set. The difference is you can't put down a channel in there, you can't put a function inside, but with set you can, it's just a function. So rather than putting a value here, I would just put down a channel float and I would just call it jump. So now I get my jump here as well, and it's not connected to anything, so it's not doing anything for me. I need to I'm translating by jump, so last step, it just multiply position by this matrix. So we are jumping and we are rotating and we are blending, and of course this should be always between 0 and 1, otherwise it would become quite extreme. So let's just set up the same thing that we had previously. So we started at, I believe, frame 24, went forward for 6 frames, go to 1, then similar to what we had there, we can just I'm just copying them from my old setup. So for the amount, which would be our spin, I'm clamping frame -24 between 0 and $f_end, which is the end here, and multiplying it by 10. And for my jump, I'm also just simply taking the same thing that we had, and now we will have the same animation. Maybe 20, just so it's a bit faster. But again, we are using Vex, so why are we writing it in there? It doesn't make sense. Like honestly, it's stupid. Like you can use one like something like frame in there, or if it's really quick you can just do it in there, but why bother with this whole thing? Well, you can actually define it in the code. Like you actually have Wrangle, so take advantage of that. In order to do this, I will be changing our setup. So I made a copy. And one thing that bothers me in this version, besides the fact that we're defining things in there, is that it's not really procedural. Like we have this frame in here, but if I decide to move it around, move it here, I have to manually go in there. And because right now it starts at 120, right? So I have to manually type in a -120 here, and then -120 here, and just let that take over, which, I mean, it doesn't make sense, right? We're using Houdini. We want things to be procedural. So I want my blend to happen procedurally. I don't want to animate it. What are the two factors that define a blend? Is that when does the blending start and when does it stop, right? But if you're setting up a UI, if you're trying to set up these parameters for your control, if I set it up like where does it start, where does it end, it's gonna be it's not gonna be easy, because I have to first of all know where it stops and where it ends, and maybe it's even easier for me to demonstrate it. So let's say we have a float start, and this would be CHF start frame. Yeah. And then float end, which would be CHF end frame. And actually, since we're working with frame, it makes more sense to actually turn these into integers, so it's just a bit easier for us to dial in the values. We can actually use the sliders. So let's say I want my animation to start at 24 and I want it to finish at 30. So now if I want to move it around, I can easily move it to like 104, but then I have to also move my end, and I have to think about what was the difference between these two? So it was 24 to 30, so we have 6 frames, so it has to be 110 now. You actually have to calculate it. So what would make a bit more sense is that we define this step in the middle, so call it CHI step, and rather than defining our animation by start frame and end frame, define it by start frame and the amount of time it takes for the animation to be done. And our end, rather than being defined by the user, would just simply be start plus step. This is a very, very simple way of essentially doing the same thing. So I'm just going to remove all my parameters, and I'm just going to come here, and I'm going to continue defining some other values. So we know we're working with time, or in this case, frame. So F would be our frame, and I would just set it up to @frame, just so I can easily call F. I don't have to type @frame, and make it a bit shorter because I'm lazy. So float F start would be equal to capital F start, which is this variable in Houdini, so means the first one, and then $f end would mean the last one. Again, I'm a bit lazy. I don't want to type that every time with the capitalization and finding the $sign and all of that, so I just define it quickly like this. All right, super cool. Now we have everything that we need to set up this blending, essentially. I would just move this comment about blending down here because this is our initial state. So initially we need to define these things, and then we would get into the blend shape now. What else do we need? We need to, what you need to do now is that our bias, it shouldn't be based on a slider. Now our bias needs to be a variable that when I define these guys, and I'm just gonna remove these two. We only care about the start frame and step. We don't care about these other channels. I wanted to look at my animation. For example, I would set it to 24, and I will set the step to 6. At frame 24, I want it to be 0. At frame 25, I want it to be a bit bigger, a bit bigger, a bit bigger, until it reaches 24 plus 6, until it reaches frame 30, which I want it to be 1. This would be my bias, right? So clearly what I need to do is map this section, this amount of time in here, to be between 0 and 1. So how can I do that? Well, we've been actually kind of doing that so far. This whole thing, frame minus a certain value, and then just clamping it. So we would just do that. I will define a new float variable, call it fcheck, as in checking our f. And what is the frame? Here we define it as f. And what is the value that we're trying to check is we're trying to see if it's smaller than, in this case, 24, which is our start. So f minus start. And just quickly, you can put down something like this to check your attribute, just so you know what's happening. So it starts from minus 23, gets bigger, gets bigger, gets bigger, gets to 0, and then 1, 2, 3, 4, 5, 6, whatever. So similar to what we had before, we are trying to, we don't need it to be minus, like our bias can't be a negative value. We only care about 0 and positive all the way to 1. So super easy way of doing this is to just clamp it. So after my fcheck, I'm gonna define a new float, and I'm just defining them as new floats because just in case I end up needing other attributes and other values from here. Otherwise, you can just say, for example, fcheck is equal to this new argument that I'm gonna write. But I just want to keep fcheck just in case I need it in the future, and I think I will actually use it again. So float anim as an animation is going to be equal to the clamped version of my fcheck And I know f check starts from I want it to be between 0 and something, right? So I want it to be between 0 and step, because what's happening here? So this attribute that I defined, and let's even just call it f check so it matches the name. And I'm just using 2 underscores just so it's a bit easier to find it here. You can even like hide your p, and this value will always be on top, even if you have other attributes. P is just the only one that would be before that. So it starts from minus, comes here, so 0, frame 24, we're going up. We know that on frame 30, our f check would be at its highest, because later on we want to map it to be 0 to 1. But above that, this value is still going, right? But when I clamp it between 0 and step, so our step is 6, right? So on frame 30, this is 6, so I don't want it to go above that. So when I fit it between 0 and step, I'm gonna get exactly what I need. And you can test that by putting down @ underline, underline, anim is equal to anim, and there we go. So it's set to 0, and then there's a brief moment where it increases to 6, and then it stays a 6. So now what do we have to do? Well, it's quite actually easy. So let me just I will keep it so we can actually keep an eye on it. So let's just fit this anim. So I know I want to fit this between 0 and 1. What value? Anim. It's between 0 and step, right? And I want to fit it between 0 and 1. So now my anim starts at 0 and goes I mean super quickly, but as you can see, it's staying between 0 and 1. And now this is a procedural animation, so I would just call my bias anim. You could have just also literally used anim here directly, but let's just recall a new function. It's not going to be expensive for Houdini. And as you can see, on frame 24, we're morphing, and we can move it to like frame 40, and it would happen on frame 40. And we can move it to frame 100, and it would happen on frame 100. And over 6, it could be over also 24 frames. So let's just start from 24 and also frame over 24. Again, like I said, total control. What else can we do? Well, just one more thing that we can do in here is that we can put down a ramp. So we can just simply ramp it up. And I'm just gonna put down the ramp here. So ch ramp, remap, and I forgot one quotation, and there we go. And now we have this ramp, and if I put it over like 24, so it's a little bit bigger, you can actually see this. I will switch to like B-spline, and I would just do something like this. So now the first, like the initial morphing would be super slow, and then it would quickly morph. You can also like bring it here, and then it would be like a super quick morph, and then it would slow down. Just something to play with, you know, more control. It can never be bad. So what about our blend shape for the amount of rotation and for our jump? So what we need to do is base it off of our time, right? So rather than just typing it in here, I want my amount to simply be a multiplier, something that I'm using to multiply speed of my animation. Same with the jump. I'm just going to remove these parameters because we are going to be making some changes here. So after my blend shape, in my spin section, I'm defining matrix M as my ident, and I will bring it down here. I will define a float value, call it spin, and I would give it this channel. Let's call it also spin. This would be our spinning speed, essentially. And for my float amount, I'm not gonna have this channel in there anymore. I'm gonna keep it as radians, but we already know that f check, which we had up here, is gonna start from like a low value, -1, and it's just gonna go up, right? So let's just use that. We will use, or you can by default, like you can use frame as well, and just multiply frame by the spin that you had, and we will get. We need to actually define it. So spin, let's give it 10, and we have the same issue that we had previously because we need to take a value off of it. So if we just use this similar argument that we had, so clamping our f check, essentially taking whatever value that we had, this would work. This would work very well for us. We don't really need to make it more complex than that. So what are the ways that we can use it? There are several ways. Number one, you can just come here and say take f minus or f check, essentially f minus step. This would be a negative value, so now we need to compensate for that, similar to what we had before. So you need to clamp it between two values, and then in this case it would be clamp it between 0 and $fn, or since we defined it, fend, and we will get this, and it's working. Like as you can see, we start here, and our transition is happening over 24 frames for the shape. So if I just lower it, it's gonna actually make more sense, look more natural. There we go. But the thing is, I don't really like this argument here. It's a bit too long. I'm not happy with it. It's fine by all means. There's nothing wrong with it. But what we could do, rather than doing that, is just simply multiplying f check, which would give us this negative. However, I can come up here and just put down an if statement. So if my, in this case, what do we call it? F check is bigger than 0, or bigger than equal to 0, let's say. Just run this whole block, and I'm just gonna put it at the end of even for jumping, because I'm gonna use the same logic there. And we are starting on the frame that we want. We're not gonna have any negative things at all. Another way to do that would be to bring in your anim. For example, we are defining all these values up here, so anim could also do the same thing. Anim goes from 0 to 1. Just put it in there, multiply it by high value. You can also just use it in there. So let's say if anim is bigger than 0, because we know by default it's always 0. So if anim is bigger than 0, just do that. And that works fine as well. Problem solved. And generally, I think I prefer using anim here rather than f check, because we will run into this thing later in the next example. Anyways, let's set up our jump as well. So I'm just going to remove this jump that we defined up there. Let's come down here. We have matrix n. What else do we need? We need to define two floats now, similar to essentially two values that we had for our jumping here. So we had the frequency, and then we had the range, or the jump, as we're calling it here. So we just need to define those. So float frec, as in frequency, and then float jump. So frec would be CHF, frec, frequency, and then jump, CHF, jump. And of course now we have two jumps, and that doesn't work. So what am I gonna call it? You can just define this as, for example, in this case, vector TR, as in translate would work. And I would just put down TR in there, and with this value, I'm gonna call back a variable that I will define right now as move. So you can of course do things in there, like just like multiply things in there, whatever you want, but I want to set it up separately just so it's a bit easier and more readable, essentially. So float move, that we will be using in our translation, we will do literally the same thing that we had back there. So we took the frame, we subtracted a rest period or our starting position, frame from it, multiply it by frequency, then clamp the whole thing, then take the sine, clamp this thing, then put it in the sine function, multiply it by the frequency, then multiply the whole thing by a range or jump, and then just putting it through an absolute function. So let's just do the same thing. We are taking the sine of the radians, in this case f check, multiplied by frequency, and then close the parentheses. Then our sine, we can just literally either multiply it by our jump here, or we can just put this outside of the absolute value that I'm gonna write. Both are fine. It's not really gonna have an effect there. So something like this, and then of course I need to create my parameters. So frequency of 20, jump of 0.2, and we will get that. There we go. That's promising. But here's the thing. I have a ramp. I like playing with ramps. Why not take it one step further? So let's set up something with our ramp. And honestly, every time I see a ramp, initially what I really want to do with it is to just like push it around, create these like crazy situations. And I would just put this on 0 just so immediately it starts after our start frame. So let's give it like something like this. I'm very hopeful I will see really cool results. I can control my spin, I can control my jump, I can control everything, and I play it, and it sucks kind of, because it broke our setup. Or did it? That's the question. So what is happening? What are we actually remapping here? So the remap value that we put down, and I can actually take this, like, I'll just keep it in case we want to look at this attribute later. What we're remapping here, down here, is our anim. Anim is a value that goes from 0 to 1, which is initially our f check. What is f check? F check is our current frame minus the starting. And how far does it go? Until it reaches the step. So all this explanation to say that this whole remap section happens over 6 frames. So now I'm breaking it up like this, like crazy. So let's set these values to 0 and just take a look at our animation without anything. Oh, what happened there? See? So it is following this logic. It's just doing it from frame 24 to 30. So this whole thing is happening there. Well, what if I make my step longer? What if I put down 120 there? So now, again, on the starting position of 24, starting frame of 24, I'm gonna see this. So now it's kind of actually acting as I expected to. Now we are getting 4 movements. Okay, that's awesome. We did it. We made it. It's working now. So let's spin. It's not working. So what's happening is that the animation, the rest of the animation, the spin, the jump, doesn't actually depend on this ramp. It's taking f check into account. And by the way, just one more thing, just for just to make sure that this is clean, I will put down this animation comment in here just so it's a bit easier to see it. And of course, just so it's separated. And of course, we're using an if statement, which I forgot to do this. So let's just hit tab for things to, you know, be a bit more logical, be a bit cleaner. Now it's a bit more, you know, readable. Any case, how can I fix this issue? What do I need to do to essentially get it fixed. It's actually not that difficult because first of all, the blend shape is working now. Like it's fine. What we could do is rather than taking our animation like this, just tweak it a tiny bit and just get it to essentially perform as I expect it. So as you jump, I want you to rotate, but then when I go back down, I want the spinning to stop. I want my character to go back to where it was. So how do we do that? The answer is very, very easily. So what you need to do is that, how are we fitting this in this blend shape? You have to realize that our anim is actually not changing throughout this setup because we are putting it through this bias. We are remapping the bias, so it's only being applied to blend. So what I will do is just I will take this and I would come up here, say anim is equal to chramp blah blah blah, and just simply put down anim here. Again, you can just use your anim to blend, and now your animation will be following exactly what you had in mind. And obviously now it's a bit too short because it's trying to do this whole thing over 120 frames, so I would give it like 600 maybe, and let's just start from 24 is fine. So we start, we rotate for a little bit, at some point we reach this ramp here, we stop, then we start back again, some point we will stop, then we will take a bigger pause because this is bigger, we go, and we stop again. And same with our frequency, so 20 here, 0.15 for example, and we have the same thing. I would even increase it to like 30. There we go. So this is working, and it's super easy because you're just remapping. So you can just remap it to the song, you can remap it to whatever, and you're done. But what if I don't want to be done? What if I want to take it even one more step further? What if what I like to have is not like this sort of adjustment? This is super helpful, but also it's not very predictable. Like I know I start from 24, that's one thing that I set up, but now the thing that we did initially here is coming to bite us in the ass because now I don't know where my animation ends. And although it's super nice to have our step when we're just trying to easily set it up, now not having an end frame is a bit difficult because now I'm like, okay, 24 plus 600, so we would finish at like 624, and then like what is the time here? Like where can I find that? So the next step for us is to again take a copy of everything and essentially set that up. So I will give myself a quick break and I will be back. All right, so I'm back from a quick break, and we're going to try to set it up. So I want a bit more control. I want to be able to actually predict how it's going to go forward. I want to be able to kind of have a little bit of an overview of how things are going to change. Essentially, this step is not like super easy to handle. So what I will do is just remove everything. I will keep my comments because these are essentially the sections that we would be setting up. And just to make it a bit cleaner, let's just bring this back. We don't need that. And I don't think we actually need this animation section anymore because we will do everything inside. And I will also remove all my parameters. So initial in this case would be replaced by counter because we're trying to set up a counter for ourselves, and the counter will count for us to get to that position. So let's define our terminology. In this case, we would have a float that I'm calling rest, and it would be a channel integer rest. So bear in mind, it's a float value, but we're defining it as an integer. I believe we did something similar back here as well. I forgot to talk about it. But in case it didn't make sense, it's because I want to be able to control integer values, but I want it to be a float, just so Houdini doesn't give me any hard time when it's calculating. So same here. We have this rest, and in our terminology, rest now means that initial pause, or pause between every cycle. So for us, let's say 24 frames. Now, what do I need? I need f now, and I'm defining f. F is not the frame in this case. It's our frame cycle. So what does that mean? How many frames do I want to have the animation, like spin, jump, etc., before going to rest? So 120, for example, 100, whatever. And we could just put this to 30, just so it's a bit, it's a round number. And what else do I need? Each cycle, like each full cycle, consists of a rest. In this case, we're setting it to 30, and then 100 frames of animation. So in a way, we can say that if we have a max attribute, it would be f plus rest. So in our case, max would be equal to 130. There we go. And then we are trying to use this data to create a counter that goes up to a certain value and then resets. So when talking about resetting thing, the first thing that comes to my mind is using the modulo function. So if you've never used it, let's define an integer, call it num as a number, and I will take my @ frame and just do a modulo over this max number that we defined. And since I'm getting an integer out of it, because I will be then later on using it in a for loop, so I want an integer, so I just put this whole thing, wrap it in an integer function. So it would give me an integer value out of it. And let's take a look at the output, this num that we just defined. So num starts from 1 because frame starts from 1 and then goes up. Our max is now 130, so it's quite high. So I would just lower my frame cycle to like maybe, I don't know, 10, and then let's give our rest 5, so it's a bit quicker. We can get results faster. So num goes up all the way up to 14, and as you can see, between 14 and 0, there's jump. So we count all the way up to 14 and then jump. What's happening with modulo? It's that it's subdivision. So we're dividing frame by max. In this case, it would be 5 plus 10, 15. But we don't care about the result. So for example, let's say we divide frame 15 by 5 plus 10, 15. The result is 1, right? But what is the remainder of this thing? It's 0. So we get 0. What is 16 divided by 15? Well, the result is 1 point something, but if we're looking at a whole number, at the integer, it's going to be 1 and then a little bit of a remaining value. So that is 1, right? And then 17 by 15, it will be 2, 3, 4, 5, just like that. So the modulo will give us the remainder. That's all we need to know. So now I have this counter that starts from 1, goes all the way to a certain value, and then resets. So in our case, 30 and 100, which are the values that we initially gave it. So I should reset on after 129. So here, the last value is 129. And then for 130, we are resetting. theoretically, you could also, for example, give it @frame -1 if you want. So you start from 0, and then you should be able to, yeah, get it on 100. On the 130 frame, you get 129. If we start from 0, I believe you get that on frame 129. So these two match. If you put down a -1 here, they'll actually match on 130. I would just go with frame. It's fine. Like I don't really care about that one frame in there. This is fine for me. And let's move on. So what I'm trying to do here now, I will write a for loop. Integer I initialized to 0. Then I would be smaller than num. It's the counter that we're getting. And I plus plus. Let's close it. And what I'm trying to get out of it is this counter. I'm trying to get this float value, for example, float counter. And I'm saying, hey, this is equal to the clamped version of my current iteration of my for loop minus my rest, and fit that between 0 and num. And if I want to check this, what I can do is just call counter equal to counter, and it's set to 0 until frame 29 or 30 in this case, and then on frame 31 it's still 0. That's why I said -1 would work. I guess a bit better, or maybe it's actually not really contributing anything. It's fine. Let's just say 31. This one frame, you just have to kind of figure out where that one is going. Probably it's because of this, maybe here. Yeah, this would actually work for me. Like starting from 1 is fine. I don't really care about it. You just need to track down where you need to subtract the 1. It's fine. I don't really care about it. And then the counter starts on this after this amount of time has passed. So let's say after 30 frames, our counter will start, and it would go up all the way till here, and then it would reset. Or if you put down this -1, it would reset 1 frame later. So on 130, and then you would reset. In any case, this is our counter. And just to simplify the usage here, if you write down your attribute after you close down these curly brackets, it's actually not going to work, because whatever variable you define inside a for loop, it's gonna stay inside. If you're defining it there, if you're defining it like this, what you need to do is just define your attribute up there, define your variable, and then just put the value in there. You don't even have to initialize it, just as long as you define it up there. So float counter, then we should be fine. I'm not quite sure why we're not fine. What is my error actually? It's because of this minus. So just so you know, in case this was also back there when I was setting it up. So float counter, you see it gives us this error, but when I cut this, and let's just say counter here, and of course semicolon, then we don't have the error. So as long as you have this definition up there, you don't even have to initialize it. You're fine. And so our counter would be carried out of the for loop, so we don't even need this attribute. I'm going to keep it just in case we want to like look back, but you don't need it. And since it's the counter, maybe it actually makes sense to just have a normal attribute. You don't need to like put this double underscores in the beginning. So what we're gonna do now is what we've done before. We're gonna get into the blend shape. So let's go to blend shape. We have position 1, we have position 2, reading it from the second one, blah, blah, blah. The only thing is, now I would like to have a little bit control over the speed of my blending. So we will have to define a certain variable there. But just before we get to that, again, we at P is equal to the lerp of P1, P2, and a value that we're calling blend, for example. Bias, blend, mix, whatever. And let's define blend. So what I want from my blend is that I want it to go from, let's just comment all of these out. I have this counter, right? Going from 0 to something. I want to fit that between 0 and 1, which is what we've done before. And that would be it. That would be how I want to set it up. So the faster and you can multiply it by a certain value, and then that would be the speed of your blending. So what we can do here is that after defining that, let's define our blend. So I have my counter, which is the information that we're getting. And if we divide that by our f, so counter goes from 0 to something, f is always the frame cycle, so counter is always smaller than f. Hopefully it would always be equal to smaller or equal to f. So if you, for example, put down a 1 in here, then that should compensate for the value that we might be missing. And this should be our blend. This should be fine. And then f at underline blend should be set to blend. So our blending value would be, in this case, it's now 0.01 because of that one that I added. Let's just take that off. It's not super important. So it stays 0 and then goes up all the way to 0.98 again. We need to compensate for value somewhere. I can figure it out after the tutorial. I forgot to do this. But yeah, we just go from 0 to 1. And that would be our blending. So we just lerp between those two values and we have it. But our animation, as you can see, it's quite slow. So what I can do is multiply this by a certain speed. So let's define our speed. And our speed could just simply be, I don't know, shape speed, something like shape shift speed. I don't know, whatever name you want to put there. And for example, I can say 10. And now the results are not going to be super nice because we play it, it morphs and then it goes overboard because it's not a clamped value. It goes above 1. So let's just clamp it. So clamp this value between 0 and 1. So it would reach 1 faster, but then it would stop. And that's it. That's how you set up your blending now. I can take this section off. Let's keep our counter. So for spin, similar to before, we would have our float spin, which would be the spinning speed. And then we have the matrix m equal to ident, which we already set up before. Now this section would be new. So we have our amount and would be in radians. We know that. And what I will put in there is the counter, and similar to our blend shape, I would just multiply that by this spin that we set up. So the faster we spin, like right now it's set to 0, put it to 10, it would start, I'm not multiplying it by anything, so it's not gonna actually give me any results. Let's just finish our argument. So now we should we should get something if I multiply v at p multiply by m. And there we go. So it's static, then it would start rotating, and then at some point it would pause and reset, and then it would rotate again. So already quite promising. Let's move on to our jump. And for jump, we would actually kind of do the same thing. So we have matrix n, ident, we have frequency, we have jump. So all the same parameters that we had before, and I would just put down some values in there that we've been using so far. And we need to define our move now. So if you recall, we had like this whole move section here. So the absolute value of sine, something, 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 and then we have the TR and then the rest. So I would just copy everything from there, paste it here. And one nice thing, by the way, is that if you hold down Shift and hit Tab, we actually remove that initial space in there that we have. But we want to change this move value. We want it to be dependent on the counter this time. So it's kind of similar to what we had, but let's use radians again, because remember, we are using sine, right? So we're using sine, so we would use radians. And then inside this radians, what I need is just my counter multiplied by my frequency, which is the stuff that we had before. And then you would just simply need to multiply that by your range or jump in this case. So I would just get the absolute value of this argument and just multiply that by jump. And let's play it. And we will do that. And at some point it would reset. And then it would start again. So pretty cool. And I'm quite happy with it. But as always, there's a little bit of nitpicking. And for me, that would be, if we lower the speed, we can see this pretty well. So we start rotating around, and then after 130, you see like this jump, this doesn't make sense. Like we're jumping from here all the way there because it's resetting. So it's going to 0. Now with high speeds is actually fine. Like with high speed, if we're set to like 40, we're not really gonna notice it, especially even if you bring up the frequency higher. But with lower values, this is a bit obvious. So what's the solution? Let's copy everything one more time, and this would be the last time we copy anything. This is the last setup. This is the boss level, if you will. So what we're doing currently in our setup is that we're multiplying our speed by this counter, and our speed is just a factor that we're putting in. But wouldn't it make more sense? And when I say speed, it means the blending speed, it means the spinning speed, it means the jump, the frequency, not jump, frequency. These are all speed factors in our setup. So wouldn't it make more sense if rather than controlling it like this, we were controlling it based on whole spins? So instead of my spin being a factor of nothing, essentially just going up, what if each whole value represented a full rotation, a full circle? So that would be nice, right? That would be then whatever value I put in, I know it always results in a full circle. It would be a bit limited in terms of the values that we get, but I think the results are worth it. Another issue that we have in this setup is that if I set everything to 0, except the blend shape, you see that the initial blending makes sense, but then we also jump. So we also need to fix that. So let's start with that. I will fix that one first, and then we can fix the other one. other two, but the other two are like essentially the same solution. And as a really like last thing here, I would like to get also a little bit more control over the height of this guy, because when it rotates, of course we have the jump, but I also want to be able to manually dial in a certain amount of height. So in order to do that, I just add a new node here. I would just add a match size. So in the first one, in the initial setup, as you can see, the cat kind of floats above air. I don't want it to float. I want to control this amount. So set these to none, but just justify y on min. So now when we sit down, we're actually sitting on the ground. Previously, it was floating above ground. So what I want to have now is this. As you can see in the jumps, now we're actually sitting on the ground, which might be what you want, and I think it actually makes more sense. But also it would be nice if we had just a handle so we could control the general floatiness of our cat. So these are the things that I want to fix in this last setup. Let's start here. We don't need to change anything in our counter. The counter is fine. We would need to essentially set up that height factor that I just talked about. So let's do that first. Float height is equal to CHF and height, not right, height. And what I would do is define a vector, call it add to height, and then set to set 0, height, and 0, and wait, not vector equal, vector add to height, and then I would just say p2 plus equals add to height. So now this is our new height, so things are fine now. And then I would keep this shape speed. I'm gonna need it, but I'm just gonna set it to 0 for now, because I have to do some stuff based on that. But later, right now it's not gonna be used. Instead of using this channel float, I will be using a ramp now. So float, and I'm just gonna call it blend. Well, we already actually have it. We already have this value in here. I just rather than using this clamped version, I'm just gonna remove this entire thing and just call it chramp. Let's call it remap. And for the value that I'm using, I would just use counter divided by f. So when we create this ramp, now we will be remapping this value to be our shapeshift. So let's set everything to 0. And as you can see, it's pretty slow. But if I lower it, it would be quite fast. So on frame 30, we would start to go, and the closer it is, the faster it would be. So I think this is a much better way of controlling things. And as an easy way to control it, this shape speed that I just generated, it's now useless. Like, you don't actually need it in your setup directly. What I want to do with it is just simply take this parameter, and I just want to control this position. So just paste relative reference, and we'll just set it somewhere around here. And the interesting thing is that now if I introduce this sort of shape at the end of my cycle, my cat will actually stand up, which is super nice. And I can use the same value to come down here and just paste it as a relative reference. And the problem is, usually when you do it like this, it would freak out a little bit paste it there, and it would ignore the 1 minus that I put in the beginning. But yeah, you see, like it becomes just like, it becomes a nightmare. So what I would do, just bring it all the way back, and I know that this is what my channel is called, so I would just copy that, come here in the second one, position, just put down 1 minus, and just manually put that in, so it always stays there. And that way I am controlling them just like this. But the thing is, you see, at some point they get to each other and then they pass each other, and that's also not super nice for us. So I would limit my shape speed to 0.5. Yeah, that is fine now. It's because it resetted also the default value. That's why it looked a bit weird at the beginning. And you can, for example, give it like 0.04 here. So there you go. Now it won't go above that. And actually what you could do is even lock it so it never goes above that. So even if you manually try to go, 0.5 is the highest. And this is a relative value, so it's not an absolute value. 0.5 relative to the amount of rest that you have. So if it's higher, it would be also higher. Or actually the frame cycle. So it would, if you put it in the middle, I believe it would be take half of your cycle to reach there. So we should see it around like 80. Yeah, and then it would come back also on 80. So yeah, pretty easy to control. And we're done with our blend shape. Let's move on to the spin. What I want to do is that I'm taking my counter, multiplying it by my spin, right? But like I said, I want to be able to have like whole values. So first of all, channel F is not the easiest way to control this. I would switch it to a channel integer, because I want a whole circle, right? So now that we have this integer value, our speed is going to be like crazy. I mean, not particularly, apparently, because it's not being actually factored in the way I want it to. And it's not a, like our speed is not dependent on doing full circles. Right now it's just the normal speed multiplier. But the way I like to do it is that this is my spin. So I'm taking my counter, starts from 0, goes all the way up, and then resets. So take that counter, now divide it by F, divide it by frame cycle. So it will always be smaller than a full circle. Now this value would start from 0, then let's say 0.01, 0.02, 0.03, 0.04, just like that, all the way to 1. So if you multiply that by 360, and since we're already working in radians, this would give us a full circle, and the spin would now give us the multiplier that we need. So if it's set to 0, it's not going to move. If it's set to 1, over the course of 100 frames after our initial rest, we would do 1 full circle, and then we would stop. If we give it 2 spins, we would do 2 full circles. So it's considerably faster, but the upside is that we don't have any bugs anymore. Everything is lined up. So 4 would be considerably faster, 4 spins. So when you say 20, it means 20 spins in a span of 100 frames, which is a lot. But now, as you can see, the moment we jump up is actually, it makes sense when we go to our position. It's much cleaner, and of course it's quite far now. We're multiplying it by 20, so that one little frame, if you recall, that I said we're missing in the middle, that's causing some issue. I would resolve this now. but yeah, this is how it's set up. And the last bit of information would be to fix our move, so our jump. And similar to what we had up there, I would just repeat it down here. So divided by f, multiply by 360, multiply by frequency. So our frequency also needs to be an integer value. And let's just create that and set this to like a reasonable value. So 10, frequency of 5, for example. And we need to give it the jump, so 0.1. And now I would also give it this like hovering value that we defined. So we would float above, as you can see. Like this controls whether we actually hit the ground when we rotate or not. So this just controls that. This is the hovering factor, essentially. And that's it. And I would just take 1 second to see what frame I'm missing to just add in there. And I would also explain it, and then we would be done. Yeah, and as I suspected, it's just this equal sign in there. So when you don't include that, when we reach the max here, we're actually resetting at 98, but this should be equal to num, so we get to actually 99 and then we reset, which would make more sense. So just same thing with our animation. So from 20 spins, and now as you can see, the spin actually makes sense and would continue to make sense even when we get to our standing position. See, it feels natural, it feels correct. It's just that one little equal that we were missing there. There we go. And yeah, that's it. That is the spinning cat meme. Have fun, make cool stuff. And I know we used the stupid cat for this, but you can always use different things. Like you can use literally just put down a box in here, subdivide it, put down like a twist node, get the top and bottom like this. Let's twist it like that. So we don't even need to like time shift anything. Just set it up, for example, like this, and we will have this animation. And you can lower the spin. You can set this to like -25 maybe. You know, it can be as stupid as you want it to be. Just have fun. Have fun, make cool things. Make it do weird stuff, and if you make anything cool with it, please share with me. Thanks, guys. Bye bye.